Good morning, my dear students. Welcome back to another session of physics class for Salma Christian Higher Secondary School. And this is for class 11th. I hope you have already gone through the note that I sent to you before. And on top of that, I'm just adding up this video so that some theory part could be explained better. Okay, this refrigerator will be working in the opposite direction to that of a heat engine. So recalling back what we did in the heat engine, there was a source at T1, and there was working substance, and there is also another sink here. This is T2. Okay, so this is the one. Then you happen to see that the heat flows from source to sink like this. It was Q1, Q2, and the the work obtained was Q1 minus Q2 here. This is what exactly happened in heat engine here. Okay. So this is what happened in the heat engine. So let me remind you one more time. In heat engine, heat flows from source. It flows from the source to the sink. And during the flow of the heat, we obtain work here, which is equal to Q1 minus Q2. And about the efficiency, we use the term efficiency last time. The efficiency was calculated as eta is equal to this work done divided by Q1 here. We calculated like this. And this was equal to Q1 minus Q2 divided by Q1 here. This was the efficiency. Now, in opposite to this heat engine, when you draw the block diagram here should be the source T1, and here should be the compressor of the refrigerator, and here should be sink again. This is kept at lower temperature T2 here. So what happened is heat has to flow in the opposite direction here. So it's opposite to the first one. But you should write as the same amount of heat Q1, Q2 here. And this time work must be done by the compressor. So this work is equal to Q1 minus Q2 again. The same work equation, Q1 minus Q2. And this is the block diagram for refrigerator. And actually this part represents inside the refrigerator, and this one is outside. Outside means like the room where the refrigerator is kept. Okay. So in short, this temperature you have T2. T2 represents temperature inside the refrigerator, and this T1, this is T1 here, it represents temperature of the room where the refrigerator is kept. Okay. Now, instead of this efficiency, when you come to this refrigerator, we use a quantity that is known as coefficient of performance here. This is denoted by beta. So this coefficient of performance beta, this is equal to this Q2, that is heat removed from the sink, divided by W here, where Q2 is the heat removed from the sink and W is the work done here. This is the way how we define coefficient of performance. Okay, so this is equal to Q2 as before, and work is equal to 1 Q1 minus Q2. That's the equation of coefficient of performance, and this also can be written as T2 divided by T1 minus T2 here in terms of temperature. So this is the actual equation for calculating coefficient of performance of a refrigerator. And as I said, a refrigerator should be working in the reverse direction to that of the heat engine. So let us not forget to mention that also. Some points to be added here. A refrigerator works in the reverse direction to that of a heat engine. Okay, this is the first part I cut here, otherwise I cannot send the video again. There will be another part again.